right. So we're going to start with the truss, and we're going to start with like the simplest truss I can think of, which is just a triangle. Okay, it's just a right triangle. Here's the simplest truss I can think of. Now I need to put a couple of things on here. I need to put a pin support. So I'm going to start with a pin support. And over here I'm going to put a roller support. Okay. I need some other information, so I'm going to put this is a 10-meter long piece. I'm going to throw some letters on these joints just so we have some common language to speak of there. B, C. Okay. And I'm going to probably want some angles. We'll call this a 90. We'll call this a 30. We'll call this a 60, just for ease of math. 36, 90 triangle. And one more thing we have to throw in here, and that's a force, a load of some kind. So I'm going to say there's a load at this point right here of 100 newtons. Oh. Okay? So that's about the simplest truss I can think of. Okay? And based on where the load is, all the way at that point of that triangle, there's not a lot going on in the rest of the truss. And that's on purpose. So we can start with a really, really, really easy one and then move on from there. Okay? So the very first step solving a truss is to understand that they are not all solvable with the method I'm going to teach you in this class. Okay? We call it static determinacy, the method we're going to use. And not all trusses can be solved that way. Okay? There's certain types of trusses, certain combinations that can't be solved that way. So the very first thing to do is check to see if this can be solved with our math. Okay? And so we're going to use this equation right here. This is on the engineering formula sheet. Okay? And it's our static determinacy equation. So we're going to first throw it into this equation and see if we can even solve it. All right, so J is joints. How many joints are in this truss? Joints where two members come together.
Three.
1, 2, 3. Two or more members, right? 1, 2, 3. There's 3 joints, okay? So 2 times 3. All right. M is members. How many members are there?
3.
3. 1, 2, 3. Okay? And R is reaction forces.
Oh.
Okay, so we don't know anything about reaction forces yet, so we need to talk that through. So a reaction force, kind of like a normal force or something, is when we're applying force to the ground or where this truss is being held, and it's sort of reacting or responding. Right? And I was pushing on Aiden's shoulder, and he was pushing me back or whatever. Right? He was providing the reaction force, so I stayed put. So going back to last week, we had these supports. Maybe it was longer ago than last week. We have these supports. A pin support. Does a pin support allow movement in the x direction? It does not. Does a pin support allow movement in the y direction?
Yes. No. Well, yes.
Yesterday you guys did the moment lab. You stuck a pin through that channel.
No.
It didn't allow movement in the x or the y, did it?
Rotation.
It allows rotation, but not y. So because it does not allow rotation, because it doesn't allow movement in the y direction, we're going to have a reaction force here. We're going to call it reaction force A in the y direction. And because it doesn't allow movement in the x direction, we're going to put a reaction force here, call that reaction force A in the x direction. Okay. So that support, that pin support, gets replaced with 2 reaction forces. All right? Now I don't know, genuinely, I don't know if that force is pushing up, if it's supporting the truss, if it's holding it down, because the truss is trying to pull up. I don't know if this is pushing to the left. I don't know if it's pushing to the right. I don't know. Okay, so when I don't know, I'm going to guess. And I'm going to guess positive. Okay, positive. So why is this positive?
It's going up.
Right, that Cartesian coordinate system. I'm guessing it's pushing up. I don't know. I'm guessing this is pushing to the right. I don't know. But when I do my math, I'll do my math, and if the number comes out negative, what does that mean?
You're wrong.
So it went the other way.
Right, I was wrong. I guess was wrong. Right? So if this comes out negative, it's actually going down. If this comes out negative, it's actually going to the left. That's fine. So we have to start something. All right, now I have a roller support over here. Okay? Does the roller support prevent motion in the y direction?
Yes.
It does. So there's a reaction force in the y direction. R, C in the y direction. Does it prevent movement in the x direction?
No.
It does not. So there's no reaction force in the x direction. Okay? Okay, so we're done with reaction forces. So how many do I have?
3.
3.
Oh.
All right. So I'll go write this over here. 3. Okay. I don't have a calculator on me. Yeah.
What's that equation called again?
Static determinacy.
I don't.
So 2 times 3.
Wait, why is B a joint?
Why is B a joint? Because these two members are coming together. They have to connect them together. Express. So 2 times 3 is 6. 3 plus 3 is also 6. Yep, it works. That means this equation is solvable. Okay, or this truss is solvable. If maybe this was a pin joint here, and I had 2 reaction forces here, then this number would be 4. Be like, we can't do it. It can't be solved using our method. Yeah.
What's M again?
Members.
Oh.
Okay? So, that's the very first thing I do, just to check to see if my math's going to work here. I've never seen, like, on a final exam, they would go, have you do this whole big truss thing and be like, ha, it's not solvable. But still, it's a good thing to check before you actually get into your, spend 20 minutes trying to solve a truss and then find out that it wasn't statically determined in the first place, right? You can't actually solve it that way. Okay, so that's our first step. We say, yep, it matches, it's statically determinate. We can start to do some math on it. All right. So, here's what we're going to do. Step 1. Unless you want to count that step 1. That's step 0. Okay. Step 1. There we go. Step 1, moment. When my teacher taught me this, I was being trained to teach this class, she said, now remember, before you start this problem, take a moment. Just take a moment. Did you take a moment before you started that problem? I'm struggling. Well, have you taken a moment? And I was like, ha 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 ha. But like 10 years later, I still totally remember that. So it was completely effective in its process, which was to get me to remember to take a moment. Because that's the first thing we want to do. We need to break into this problem. We need more information in this problem. We need RCY or RAY or RAX or something on one of these 3 numbers. We need more information. And how we get that is by solving for a moment. That's the first thing we want to do. Okay? So this is how this works. We imagine, we go to the pin joint, and we imagine this triangle kind of like rotating around. Spinning around that A. Okay? So, what would cause that to happen? What would cause this truss to move about A, to rotate?
Pushing on C.
Okay, pushing on C. And what else?
Pushing left on B.
Yeah, well, there's nothing there though. I agree, but there's nothing there.
Oh,
This force is here to cause the truss to kind of do that.
Pushing down on C.
Yeah, this here. Right, that's the other one. Okay? So, I know the sum of the moments must equal 0. How do I know that?
It's static.
Static. If the sum of the moments didn't equal 0, this thing would be spinning. Right? So I know that the sum of the moments must be 0. Yeah?
It's static because it's 6 equals 6, right?
No, it's static because it's not moving. We can solve it using this math because 6 equals 6.
Okay.
If this didn't, it wouldn't mean that it's moving. It would just mean that we can't solve it using the procedure we're using. Okay, so all the moments have to add up to be 0. Okay, so what are the moments? So we'll call this, I don't know, moment force, for lack of a better term. Now, is that, you need to kind of critically look at this, is that force going to cause this thing to rotate clockwise or counterclockwise?
Clockwise.
Clockwise. It's going to want to cause it to go that way, right? If I push down here, it's going to want to cause it to do that. It should be clockwise. It's clockwise, positive or negative?
Negative.
Negative. And we know that because we decided. We said
Good, sir.
clockwise is going to be negative. It just is. Okay. So then what I have to do is I have to say, that's a negative. I don't know what that moment is yet, but I know it's going to be negative. All right. And why isn't it spinning? It's not spinning because
RC1.
The moment at C here, right? Moment at C. So moment at C, is that trying to move this truss clockwise or counterclockwise?
Counterclockwise.
Counterclockwise. So that's going to be positive or negative?
Positive.
Okay. So I know the moment force and the moment at C. What do I know about them?
They have to.
They're going to be basically equal, right? There's only 2 moments here, so they're going to be basically equal.
Yeah.
I'll add moment force to both sides, so I know that MC must equal M force. Okay, great. But now I need to know one of those things. What is the equation for moment? Distance times force. Very good. Okay. So moment force, for example, is going to be distance times force. Okay. What is the force?
Oh, 100 newtons on the RCY.
Yeah, that one's given, so I'll just write that in. So moment force equals distance times 100 newtons. That one's given. Okay, now distance. All right, so distance is a little tricky here. Okay, what is it that we know about force and distance for a moment? What do they have to be? F. Something about the orientation. How does it have to be aimed? What? Perpendicular. Yeah, force and distance have to be perpendicular, right? So if my force is going this way, it's straight up and down. What distance is perpendicular to that?
10 meters.
It's also the only distance I gave you, but that's going to be my distance. It's perpendicular to that distance from A. So it's 10. So I'm going to go ahead and put in 10 here. So moment at F is 10, call it meters, times 100 newtons. So moment at F is 1,000 Newton meters.
Yeah.
Okay? Cool. So that is the moment, that's how much rotational force, for lack of a better term, this force right here is putting on the truss. It's trying to rotate it with 1,000 Newton meters. Okay. Now, what do we know about MC again?
The same.
It's got to be the same, right? They got to be the same. So I know MC. What's MC?
1,000 Newton meters.
1,000